Hello and welcome. In this video, we establish the purpose of HVAC systems and the foundational role of sound definition in delivering comfort and acceptable indoor air quality. We will frame HVAC design around two simultaneous objectives. First, offsetting building sensible and latent loads, and second, providing outdoor air to dilute contaminants as required for indoor air quality. We will define key terms, build a rationale for sound definition, and preview how these choices influence air distribution systems. This section contains, first, indoor environmental objectives, so this means what conditions the system must achieve. Second, how sensible and latent loads together with ventilation define what the air side must do. Third, sound, how we partition a building so control is meaningful. Then we connect sounds to system behaviors such as constant volume and variable air volume control at a conceptual level. And finally, we tie these choices to energy and sustainability outcomes that matter in practice. The learning objectives. By the end of this video, you should be able to state why HVAC system exists and how sound definition supports both comfort and indoor air quality. Let's start with a question. Imagine that you are handed a design that says a single air handler with one thermostat serving an entire floor that has rooms with different uses. What mismatches might emerge between what the system delivers and what different spaces actually need? Take a moment to picture three distinct areas: an open office with a variable occupancy, enclosed meeting rooms with short high-density events, and a print or copy area with process heat and emissions. If one control point is expected to keep all these areas comfortable, what happens when the conference room fills up while the open office empties? What happens to humidity control when the print area adds latent loads? As you think this through, separate sensible and latent effects, and remember that outdoor air is introduced for indoor air quality, not just temperature control. How should this diversity influence the performance of the air handler for the whole floor? Keep your answers in mind. So let's start with indoor environmental objectives. The primary purpose of HVAC is to create indoor conditions that are comfortable for occupants and supportive of health. This requires offsetting both sensible loads associated with temperature change and latent loads associated with moisture removal or addition under expected operating conditions. In parallel, outdoor air is supplied to maintain indoor air quality by diluting contaminants from people and processes. The system must therefore condition and distribute air to satisfy both thermal and indoor air quality objectives. Then let's talk about loads and ventilation requirements. Building envelope characteristics and solar exposure determine a substantial share of the sensible load that airside must remove. Internal sources, occupants, lighting, and equipment contribute both sensible gains and, in many cases, latent loads that the coil and air distribution must handle. To meet indoor air quality, the system maintains a minimum outdoor airflow mix with return air. That minimum must be provided even during part load conditions, which has direct implications for control design. Now let's talk zoning fundamentals and criteria. A zone is a portion of the building that shares set points and operational schedules, so a single control signal can represent its needs. Effective sound design groups spaces that exhibit similar internal gains, occupancy patterns, and envelope exposures. This limits cross-interference where one spatial needs compromise another's. Practically, each zone should have sensing, a control point, and a means for the system to adjust delivered conditions, like airflow, temperature, or both, independently of other zones. Now let's talk about the air system distribution in a zone. In constant air volume system, supply flow is essentially fixed and the system meets varying loads by changing supply temperature, often introducing reheat per load to avoid overcooling. In variable air volume systems, some terminals modulate airflow to match sensible loads while maintaining a minimum flow to satisfy ventilation and air movement needs. The benefits of sound designs are realized only if the chosen system can vary delivery to each zone in a controlled way. Otherwise, zones compete for limited control authority. Some designs implications for energy and sustainability are when zones are poorly defined. One area's needs may force conditions that require reheat or that cause discomfort elsewhere. Aligning the control approach that could mean choosing between constant volume with reheat versus variable airflow. So this aligning the control approach with expected load variability can materially reduce cooling and reheat energy over typically operating hours. Early decisions should consider maintenance access and likely changes in occupancy or use so zones and systems remain effective over time. So let's recap and mention some key takeaways from this video. Successful designs address temperature and humidity alongside ventilation. Sound design is the lever that makes control precise and fair across diverse spaces. So you should choose architectures that can actually deliver different conditions to different zones. So I invite you to continue learning about these topics. If you want to go deeper, study how the state points define coil performance and dehumidification under summer design. Explore how part load behavior differs between constant and variable airflow approaches and why that matters for energy. Finally, I suggest you to review control sequences that preserve minimum outdoor air across operating conditions. Thank you for watching this video.